Okay, so I just wanted to take a couple minutes to do a really quick video on events because we're going to see events come up a lot when we start working with WPF. So I want to make sure that everybody kind of understands events from the ground up. So the entire kind of thing is predicated on the idea of delegates. And so I also want to take a step back maybe and kind of explain what a delegate is at the same time. So at the top of this class here, we have a field that is declared as a delegate. And essentially what a delegate is a function pointer. So you can think of them as function pointers in C++, except that function pointers in C++ can do a lot of stuff that delegates in C# cannot. So delegates in C++ or delegates in C# are object-oriented and they are type-safe, which means that you will always understand the return type of the method that you're referencing. You will also have a strongly typed list of parameters that are going into that delegate, and the delegate itself exposes a type. And so what you will find is that in C++, you can use function pointers to essentially point to a function, and then a whole bunch of errors can happen at runtime if the code isn't structured correctly. Instead of doing that, what C# does is kind of pull back on the functionality of delegates in a lot of ways, but requires the contracts of delegates to always be consistent. So what you'll find is if you want to call or invoke a delegate, you will always have to have a method that matches the signature of the delegate that's provided. So I'm going to have a method that returns a void, and it's going to have to accept a string. And if I don't have that, I'm not going to be able to use the delegate, and the delegate's type allows us to enforce that. So that is kind of a very brief sort of comparison of the two. There are a lot sort of case-by-case use cases that are different, where you can do things in C++ that are nice to have, but they also expose you to maybe doing things that you shouldn't be doing. And I put a link in the Canvas page on delegates to kind of outline exactly what those things are. So coming back to events, we talked about really there are three components of events on the Canvas page. And the first one is declaring a delegate. Because under the covers, all events are of a delegate type. So here what I have is a class that is a producer, and I have declared my delegate type up top, and this delegate type is produce. And then on the second line, I've done the second step, which is creating the event itself, which is called onProduced. So I have created something in this case, and then that event is of type produce, which is a delegate. So these two lines of code are the first two steps to glory for an event. So the producer class, in this case, also actually uses events to invoke this delegate. And so I'm going to go through that a little bit. So this timer class, what this does is it actually allows you to create a stopwatch and then fire methods once the time on the stopwatch has elapsed, so or on the timer has elapsed. So here what I'm doing is in the constructor of my producer class, I'm creating a timer, and then I'm setting it to 10 seconds. And so this is accepting a parameter, and this is in milliseconds, so I have 10,000 milliseconds for 10 seconds. And then I have this event, and so the timer has an elapsed event, and what I'm doing here is the third part of events, and that is subscribing. So what I'm doing here is I am passing a delegate to this operator, and this operator is subscribing this method or method group to this elapsed event. So this means is my complete production method is going to be used as the event handler for the elapsed event. And this whole process is called subscription. So here I have subscribed to the elapsed event on the timer. And the moment that this producer instance is garbage collected, it would automatically unsubscribe. So this is a for the life of the entire object. I'm going to be subscribed. If I wanted to unsubscribe, again, I could programmatically use the minus equals to unsubscribe. So there are two additional things I need to do on the timer class. Here, or the timer object here. First, I want to say that it's going to auto reset, which means every time I go to 10 seconds, it's going to automatically put another 10 seconds on the clock. And I'm going to set timer.enabled to true, which means it's going to be running the moment that this line is hit. So if you're familiar with diagnostics.timer or the timer in Java, this is equivalent to timer.start. So when I create my producer instance, that producer instance is going to have a timer wrapped inside of it. That timer is going to raise the onProduced event every time the elapsed event is happens or fired. Because I am calling the complete production method as the event handler. So down here, every time 10 seconds elapses, this method is going to be called. So if you look in the parameter list of complete production, this parameter list and the void return type is the same signature as the delegate that implements the type for the elapsed event. So here I have a elapsed event args. You're going to see this over and over and over again. So there will be on-clicked event args, there will be keystroke event args, so on and so forth. This is a very popular coding pattern. And so we could have actually added this up here if we wanted to have our own class that implements our own sort of types of information that we could use when raising the event. But we're raising kind of a primitive event, and that primitive event is essentially just broadcasting to the cosmos the word unit. So here we could just as easily have had some private variable set that has a product name or something like that. And we could raise that event with the variable value instead of the literal here. Doesn't really matter. I'm just trying to show you kind of the skeleton. So what is happening here, one more time, is I have an onProduced event. That onProduced event is a event of type produce, which is a delegate that we have also declared inside of this same class. Inside of the constructor of the producer class, which creates each object, I am establishing a timer, and that timer is set for 10 seconds. And every time 10 seconds comes off of that clock, the elapsed event on the timer will be fired. The event handler for that elapsed event is complete production. Complete production actually fires our onProduced event, which broadcasts to all of its subscribers that a unit has been produced. Underneath the subscription, I have auto reset has been set to true, which means that every time 10 seconds comes off the clock, it will be reset to 10 seconds. And enabled has been set to true, which means that the timer is actually going to be running the moment that this object is created. So that's the producer class. In my program, what I have is just my sort of standard main method, and I have this static void producer onProduced method. This thing looks exactly like the automatically created event handlers for WPF, which we will shortly see. So inside of this, you will see that it has a void return type, and it has a string item inbound parameter, and this matches the delegate over here. So again, this matches the void string item signature. what I'm going to do is I am going to print the datetime.now. I'm going to use my string formatting character inside of string interpolation, and I'm going to set it to be the day, month, year, and then the hours, minutes, seconds, because I want to actually see that every 10 seconds a new unit is being produced. So every time I call this method, I'm simply going to write to the console the date all the way down to the seconds, and the string producer made a new item, and item is being passed into the method. Okay, so in my main method, I'm going to create a new producer class. So this producer is going to be an instance of our producer class we just went over. And I'm going to subscribe to the onProduced method. So again, this method we just created over here. And I'm going to subscribe the method down here, which matches the delegate that is the type for this event. And so because this signature matches this signature, I'm all good, and I'm going to be able to actually subscribe. If I wanted to unsubscribe immediately, I could use the minus equals instead of the plus equals, but for now, I don't want to unsubscribe. I want to subscribe and then see what happens. This is an arbitrary kind of way to keep my console window open. So what I'm doing here is I'm going immediately into an infinite loop. This will simulate largely what you would see on something like a web service that is running constantly in the background. What's going to happen is the window should open, and it should stay open until I Control-C and kill the window, and it should print this message roughly every 10 seconds. So we're going to run that up. So I get my window. And so my first unit has been created at roughly 11:28 and 9 seconds, and then 19 seconds, and then 10 seconds on video is a really long time, but eventually I should get to 29 seconds. And so here we see indeed that every 10 seconds I'm going to fire this method down here. So how is this different from stuff that we've done so far? This is different because we are not necessarily seeing synchronous code running all of the time. What we're actually seeing is this window is stuck inside of a while loop for forever, but in the background, another class has kind of taken over the program and is going to constantly fire events. And all that's going to happen in my main program is I'm going to take and handle those events. I also see a mild bug here, and let's work through that really quick. Oh, they should be lowercase, so let's try that again. So 10 seconds in infinity again. And now I have 2020 instead of a bunch of Y's that mean nothing. So again, this is basically just, you can think of it largely like the dispatcher loop on your processor, or in your operating system rather. This is going for forever. And even though my main method synchronously is just going through this while loop for the rest of its life, I'm always able to process something in the background, essentially, because this guy has a timer, and that timer is asynchronously firing events. And this class is busy running the while loop, but has already set up an event handler for the elapsed event on that timer. So I hope that this kind of makes sense. We talk a little bit also about some kind of bad stuff that can happen to you in terms of handling events, and so maybe that's worth mentioning. So the biggest thing that is really, really problematic with event-driven design is trying to orchestrate the order in which events are raised. So we go through the example of trying to buy the last package of toilet paper, for example. If there are 3 people vying for that last package of toilet paper at the same time, and then one person buys it, but it takes 6 or 7 seconds in order to fire the event that there's no more toilet paper available, this coding pattern really kind of fails, because as you can see, if it takes 10 seconds to fire the event, it's very possible that I could go in and actually buy something on Amazon in that 10 seconds. If I already had it in my cart, I could very easily click the checkout now button. And so you can, in your mind, even without a whole lot of experience, understand that there are tons of situations you could get into that you don't necessarily have a clean solution for. And so this is maybe not an excellent coding pattern in general. It certainly has its time and place for UI-driven development. You definitely want a button click event. You definitely want tab out or lost focus events, but you don't necessarily want to be in a situation where you're developing a console-based app entirely based on events, or some sort of very large business structure based entirely on events, because in a lot of ways, if your code stack gets too big, it's basically like orchestrating an explosion. You have a whole bunch of events being fired. You can never really ensure that they're going to be fired in the right order. And so you have to make sure that all of your event handlers can handle all of the possible orderings that they can get. And that becomes obviously a very, very difficult situation to handle. So we're going to see events a lot as we go through the rest of the course, particularly for UI development. But outside of UI, there are several other use cases like timers that have to go off that remind you to do things, so on and so forth. But in the abstract, events themselves as a complete kind of architectural decision, or they maybe leave a lot to be desired. So I hope that this provides at least a background on events and what they look like in C#, and gets you kind of started on what they look like and how to implement them. So thanks very much for tuning in, and I'll see you in the next video.